Hey everyone, Nitesh this side. Hope you are doing good. So let's start with the question. So the question is evaluate division. Okay, so you are given an array of variables where equations and an array of real number values. Okay, so you are given two array, one is equation and another is value. So where equation is ai comma bi and value I represent the equation. Okay, so equation is always ai divided by bi equal to value I. Okay, so you are given an equation. So this is AI BI. So it's basically mean AI divided by BI is always equal to value I. Okay. So what you have to do, so each AI or BI is a string that represent a single variable. Okay. So you have to given some queries where queries j equal to cj dj. You have to represent the jth query where you find the answer for cj divided by dj equal to. Okay. So you're given a query list also, which you have to find out the result for that and return the answer of all the query. If a single answer cannot determine, return -1.0. Okay, then what's the node? So input is always valid. You may assume that evaluating the query will not result in division by 0 and there is no contradiction. Okay, so input are always be valid. So it's not always like 1 divided by 0. So it is always valid. Okay, so let's understand with an example. So we have this given this evaluate division. Okay. So let's take this equation. So we have given this a b. Okay, which is equal to this value. So a divided by b is equal to 2.0. Similarly, b divided by c is equal to 3.0. Okay. So now let's see the queries. Okay. So what's the query? So first is you need to find a divided by c. Okay. So this is your given input. Okay, you need to calculate a divided by c. So how can we calculate? So let's multiply both of them. So a divided by b into b divided by c, which is if I put the value, if I just cut this down, so this will become a divided by c, and if I just put the value 2.0 into 3.0, so it is 6.0. Okay, so as you can see, for this we are having an output of 6.0. Okay, let's calculate for b divided by a. Okay, b divided by a, which means b divided by a. We know a divided by b, so we just do the reciprocal of that. So we do 1 upon 2.0, which is 0.5. Okay, so for this we are getting the output as this. Okay, let's see for a comma e. Okay, a comma e. Now you can see we only have three inputs variables. So one is a, then we have b, then we have c. So in these three variables we have a relation. We don't have a relation with this e. So if there are any variable which is not existing in our current flow, so we just return -1 for that. Okay, so that's why it is having a -1 here. Let's see for a comma a. Okay, so a divided by a, which is like always the same value, so it's 1.0. Okay, now you may say like x divided by x is also, you can say 1.0, but x is not exist in our in given input, so we will just return -1. Okay, so we got the question like what we need to calculate, how, but how can we solve this question? Okay, so let's see. So basically we have this a divided by b and b divided by c. What we can do is, let's write it like this. We have a and we have b. This is a, this is b, and if I have to go from a to b, okay, let's take, this will take a value of 2.0. Okay, now if I have to go from b to a, so let's take a reverse from this direction also. So this will be 1 by 2.0. Okay, now let's take for b divided by c. B divided by c, which is, if I have to go from b to c, it will be 3.0. And let's say if I have to go from c to b, so then it will be your basically you will do 1 by 3.0. Okay, so you can see we have created a graph. Okay, and it's a directed graph because we are given a direction. So what we will do, we will apply the DFS on the queries. Okay, so let's say our first query is calculate the, for this a divided by c. So what we will do, we will start from our source. So this we will assume first node as a source and the second will be destination. We will start from here and we will apply DFS. Okay, and we will check if we are able to find out the C path from the A, then we can return the output. So how can we return? So from A we can go to B. Okay, so we having a output of 2.0. Then from B we can see we can go to C. So as you can see, C is our destination, so we just return from here. And after this we will also calculate the basically product between them. So 3.0 into 2.0, which is 6.0. Okay, let's take for B divided by A. So for this, B will be our source node and A will be our destination. So we can see there is a edge between them. So we can just directly do the DFS and find out where is the destination. So we can able to find out, and we just return the this 1.2.0, which is 0.5. And if any node that is not present, so for that we just return -1. Okay, I hope it is clear to you. So let's write the code for this. Okay, so what we need, we need to form a basically graph. Okay, so like we can take a normal list type of graph, but it is not sure, like it's not in a 0 to n minus 1, it's in the string format. So let's take a map of graph. So we'll take a map of string and list of basically each node represent all the edges that is connected to it. So we'll take a type of node. Okay, why we take a node, let me explain you. So we'll create a class node which will have two values. First is key and another is that will be of double type value. Okay, let's create the constructor for this. Okay, let's give the same name. This will be string and this will be double. My bad. Okay, so key will point to k and your value will point to value. Okay, now first step is to create a graph. Okay, so how we will calculate the graph, basically create the graph is, first step is to create, initialize it, hash map, and then we do basically over our values we will initialize it, values dot length. Okay, it will be list. Okay, it will be array, so values dot length will find I plus plus and will do. Okay, so what we will do, first we'll calculate the source, find out the source. So source will be equations dot get I dot get 0, and we'll take the destination also. So destination is this. Okay, now after this what we will do, we will initialize our graph like the list node. So we will check if it is not initialized, so put, it will be like graph dot put if absent, initialize it, initialize the source. How we will initialize, we just give the array list. Same we have to do for destination also. So we'll do for destination. Now we'll insert the variable into our list. So how we will insert it, we'll do graph dot put, we'll give the key is source, and now our value will be node type. So we'll create a new node, and like source will have a connected to destination and having a values of I, current I. Okay, similarly we have a graph dot put from like from the, we have a two direction, like from source to destination and from destination to source also. So destination will also point new node source, and this time they have a reciprocal of the current value, so it basically 1 divided by values. Okay, values of I. After this I think we have done with the creating the graph, so we have built our graph. Okay, after this we have to do the DFS over the queries. Okay, so what we will do, and we have to return a double array. So let's take queries dot size. Okay, Then we initialize our answer. Okay, and we'll give n. After this, what we will do, we just have to return our answer, and let's do the loop over our queries. Ni plus plus, what we will do, we will do answer I equal to DFS. We'll pass the queries dot get I dot get 0. Then we'll give queries dot get I dot get 1. So this is basically 0 means source and 1 means destination, and we'll give some sort of a visited set. Okay, so we'll take a hash set, so that like in DFS, if we don't have a visited array or some sort of a list or set, then it will iterate again and again, so we have to stop it some place. Okay, so I think this look good to me. Yeah, so let's write the double DFS implementation. So this will be of type source, string type, source, string, destination, and will give a set of string of set. Okay, so first step is to check whether this source or destination is present in our graph or not. If it is not present, that means we can't find a path between them. So we just check if graph dot contains key source or, and similarly I'm doing the reverse of the contains, graph dot contains key of destination. If it is not present, okay, just return the 1.0, basically minus 1.0. Okay, and if your source is equal to your equals to destination, just return 1.0. Otherwise we'll iterate over our child. So we will iterate node of child, we'll do graph dot get source. Okay, before this we have to make our current source as a visited, so we'll set dot add source. Now we need to check if set dot contains this child dot key. Basically if it is not present, then do your work, otherwise you don't have to go. You have to do double, let's take a variable, so we'll call the DFS, we'll pass the, now our source will be changed to child dot key, destination will remain same, and we'll pass the set. Okay, and let's say if in the return if answer is not equal to -1, what you will do, you will just do return answer into your child dot value. So that's why we are taking a node, we are taking key and also value, so we just return value from here. And finally, if let's say you are not able to get the answer, you just return the basically minus 1.0. Okay, I think it's look good to me. Let's source destination, yeah, let's run it. Okay, so there is one mistake we have done. What is that? So graph dot put, okay, sorry, node cannot be converted to list of node. Okay, so got it. So we are just directly putting it, we have to, like it's a type of list, so we have to do get source dot add new. Okay, so it will be like this, so my bad, so it will be get destination dot add new node. Okay, let's run it. Okay, as you can see, this is accepted. Let's submit it. Yeah, okay, so our code is submitted. The time complexity is basically we are building a graph, and after that we are like building a graph is just a order of n, but we are doing a DFS for all the queries. So it's basically your graph basically equation length dot queries dot length. So if you take equation as n and queries as m, so it will be n cross m. Hope you like it. Thank you for watching my video.